Hello, welcome back to Mr. Class. Today we are entered to chapter 1.3 Stoichiometry. These are the objectives in chapter 1.3. However, in this video we will not discuss this objective yet. Okay, let's recall what you learned before. In a chemical reaction, how much product formed is strictly depend on the amount of the reactant that available. For example, how many of cupcakes that you can make will be depends on how much sugar you have, flour you have, butter, or any ingredients that you need. Okay, so this is what you learn in SPM. Mainly in the question, maybe you will given the product and then ask you to find the amount of one of the reactants. Or the other way around, give you amount of reactant but ask you to find the amount of the product. Or another one, they give you one of the reactants and then ask you to find another reactant. So basically there is the relationship between reactants and products. When a chemical reaction is given and you ask to determine the amount of reactant used or product formed, basically you need to do the following step. First, you need to have a balanced chemical equation. Based on the information given, determine the number of mole, followed by compare two substances based on the chemical equation. And step 4, you are going to determine the number of mole of the other substance. And then finally, you need to convert the number of mole into mass, volume, or number of particles based on what the question requests. Still remember the step that we revised just now? Let's recall. First, we need to have a balanced chemical equation. Second, we need to find out number of mole. Third, we need to do the comparison between two substances. 4, we're going to determine another number of mole. And lastly, we will going to convert the number of mole to mass, volume, or particles. Okay, so now let's apply these few steps in tutorial question. We start with tutorial question number 3. Roughly go through this question, you will notice that in the question already given us the chemical equation, so you no need to write the chemical equation yourself. Continue reading the question. We need to find out the mass of sodium bicarbonate, and then we are given the mass of the carbon dioxide. So step 1 done. So now we need to proceed to step number 2 to determine the number of mole of carbon dioxide. After we determine the number of carbon dioxide, we're going to do comparison, which is step 3. In this comparison, you will notice we compare carbon dioxide with sodium bicarbonate. Why we compare these two? Because carbon dioxide given, and then question asks us to determine sodium bicarbonate. After we compare with this 0.466 mole of carbon dioxide, we're able to determine number of mole of sodium bicarbonate that is used. And after we get the number of mole of sodium bicarbonate, lastly, we convert it to mass, which is requested in the question, 78.29 gram. Okay, let's check out one more example together. Still remember the 5 steps. First, go through the question. You are given the chemical equation. What would be the volume of oxygen? Unknown. Release. From the 250 ml of 2.0 molar H2O2, this one is given. So step number 2, we need to find out number of mole for H2O2 hydrogen peroxide using the formula mv over 1000, which equal to 0.5 mole. So step number 3, we need to do comparison. In this question, we are going to compare oxygen with the hydrogen peroxide because this is given and then this is asked us to determine. So you can simplify writing like this. So compare and then this is the number of mole of oxygen gas that's produced. And then step number 5, we are going to use number of mole to determine the volume because the volume is because the condition is STP. That's why we need to multiply with 22.4 liter. You can refer this mapping to do conversion between number of mole with mass, number of particles, and also volume. There is always two conditions when you want to determine the volume. First condition is at STP, at where the temperature is 0 degrees Celsius, and then the pressure is 1 atm. The molar volume for at STP is 22.4 liter. Another condition is room condition, at where is referred to 25 degrees Celsius and 1 atm. But the molar volume is slightly different with STP condition. Molar volume at room condition is 24 liter. Okay, another formula that you can remember to determine the number of mole is mv over 1000. This formula normally can help you to determine number of mole for aqueous solution, at where the m is referred to molarity, while the v here is referred to volume, which is in unit of centimeter cube or milliliter. Okay, now we are in question number 5. As usual, when we read through the question, we notice there is a balanced chemical equation. Continue reading the question. You are given 10.9 grams of methanol. Okay, and then the question asks us to determine number of molecule of oxygen gas. Okay, so now let's proceed to step number 2, which we're going to use 10.9 gram of methanol to determine number of mole by dividing with the molar mass, so which is get 0.3406 mole of methanol. Okay, step number 3, we are going to do the comparison. In this question, we are going to compare methanol with oxygen gas because one is given and then another one is request to find. So 2 mole of methanol react with 3 mole of oxygen. So if in this case we have 0.3406 mole of methanol, how many mole of oxygen will be needed? So we are going to use crossover multiplication. Dalam silang in bahasa, 0.34 times with 2 divide by 2. So this is step 4, number of mole of oxygen that we get. After we get the number of mole, in this time, the question is asking us to determine number of molecule, which is mean number of particles. So if you have number of mole and then you need to determine number of particles, we are going to multiply with the Avogadro constant. number of mole multiplied with Avogadro constant, then this is the final answer, 3.08 exponent 23 oxygen molecules. Okay, now it's your turn to try out question number 5B and 5C. These are the final answer for this question. This is the last tutorial question that you can try out yourself before we continue with limiting reactant in the next video. Thank you.